Welcome to the Red Onion Press. We're a fine arts printmaking facility here in Kennesaw, Georgia. We also do restoration. We've done restoration of presses, letterpress primarily, and now we've got an interesting project that we've been given, which is the restoration of a 19th century freight scale from Acworth, Georgia, that the Save the Acworth History Foundation in the city of Acworth is planning on installing in a replica of their railroad depot. So today what we're going to do is we're going to explain how the scale works. Well, we're going to demonstrate that with some weights. To begin with, let me go through the parts of the scale and then we'll test it out. Okay, so this part of the scale, many of you might be familiar with, having seen these in doctor's offices, where they weigh you when you come in. And this part has two weights, one that weighs 0 to 100 pounds and the other one from 0 to 200 pounds. So this is double the weight. This is the fine tuning of the scale. At this end, the scale has an indicator, and when it actually weighs something, the indicator is balanced between the top point and the other point. So you have about 3/4 inch of motion between below or above the weight, a floating state where it's level. Over here what we have is a place where you add counterbalance weights. A counterbalance weight looks like this. This is one that is for 300 pounds. It says 300 pounds on here. What that means is that if you place this at this end, that when you put 300 pounds on this scale, you should be able to equalize this weight proportionally to this weight. Now, how does that happen? Well, the scale actually has a whole series of levers. Levers are one of the most important elements of a machine design in both modern and throughout history. So this is connected through a lever here that has a balance point, and then a series of levers down below. What you have in the bottom of the scale is what you don't normally see, but we'll be able to show you. So this part of the scale, which is usually referred to as the beam, has a pivot point here, which is called the fulcrum. So this is one lever, and then through this part going down to the bottom is a whole nother lever that is about 6 feet long. And that has another lever that it raises that's about 2 feet. All this together was designed so that whatever weight here is placed on can be proportionally read with a manageable set of weights and to achieve equilibrium and hence be able to calculate the weight of the object that you're weighing. Interesting features of this 19th century scale is the technology that had been developed to enable them to get such a precise motion and be able to measure that with the scale. So in the process of operating the beam, from moving it from too heavy to too light, we get a range of 3/4 of an inch. And in the dial indicator that we have on the base, we can see how much movement that actually is. And as you can see here, it's about 4/1000ths of an inch, which is about the width of 2 pieces of paper. One of the things that you can find throughout every moving part is the kind of bearings that they developed for the scale. The term is knife edge bearings, and if you look at it, you'll see that the contact point between the moving parts on the scale, everywhere throughout the scale, the connection point is a knife edge of a round member, much different than anything I've ever seen in contemporary machinery. But by doing this throughout the machine, they're eliminating a good deal of the resistance to motion, the friction, as it were, by having a single point connection, and allows the weight of the base to be reflected throughout the machine with the least amount of resistance. So that was an important technological development that they came up with that enabled the scale to be as accurate as it was. The other thing that's very interesting about this scale, and that is unique, a set of 4 ball and sockets support the heavy steel plate of the scale. The ball and sockets eliminated the problem of the wear and tear on the scale when large objects or heavy objects would be placed on the scale and cause it to move. The ball and sockets would absorb the motion and prevent wear on those knife edge bearings, which would keep them from wearing down rapidly. That also helps us determine the oldest possible date of the scale. Since this was only developed in 1857, the scale has to be younger than 1857. The exact age we don't know, but we do know that these scales were in use well into the 20th century. All right, that looks like it. And reading between the top and the bottom, I have 20 pounds here and 4 pounds at the top, a total of 24 pounds. So at this point, we know that with nothing on the scale, that this is the reading that we're getting. And if we add anything to this and measure it, then we'll take this weight and subtract it from that weight to determine the actual weight of the object that we place on the scale. So here I have 3 weights that came with the scale. They're different sizes, but they all are marked 3 pounds. And I have a bathroom scale, which is not very accurate, but for our purposes, fine. And I'm going to go ahead and put my 3-pound weights stacked together on my scale, which gives me a total reading of 9 pounds. Then I'm going to take these 3 and place them in the center of our platform carefully. Now, if you'll notice, the beam is all the way in the up position, which means that there's more weight at this end than there is in the counterbalance. And we're going to move scale, or 100-pound scale indicator over and we are now reading between the two 20, 30, 1, 2, 3, 4 and a half pounds. So 34 and a half pounds shows that we're about 1.5 pounds over in the reading, and it may be very important to have this adjusted correctly to be able to get the right scale factor between the counterbalance and the weight below. We're going to experiment with that before we finish, after we've reassembled the scale, and see if we can actually calibrate it. But you can see that we're very close, considering the fact that we are using a makeshift connector here, and considering all the rust and the cleanup that we need to do on the scale itself to get it ready. So at this point, I'm pretty satisfied that we have all the parts, all the parts are working, and the scale is capable of reading a weight.